Hello, everyone, and welcome to week 2 of Precalculus in ECDE Foundation. Today, I'll be reviewing over Algebra 2 concepts that you must know in order to master Precalculus. The first one is this idea of the perfect square. And so if I give you a certain equation here, so if the equation is x squared plus 10x plus 20, and you want to transfer this so that the given function will result as x plus h squared plus k. And know that h and k are variables, right? So variables can be any number, but you want to make sure this is what is supposed to happen. And so many people would do this. They're like, this is an easy question, right? It's x plus 10 and then plus 20. Does this work out? Well, look at this question here. It gives you a square right there. It's a little square here. That's what should be known for everyone that does this, right? So if I go back, that's an incorrect step that many people do, even in Precalculus. So the first thing you want to do is you want to find the perfect square. And so when doing this, you notice that this 10 when divided by 2 will give you 5 plus 5. And when finding the perfect square, here let's look at an example here. Plus cx plus f, right? C and f are both variables. So let's look at the variables a and b, right? So for this equation, a plus b has to equal c, but then a b equals f, meaning that a times b has to equal f, right? So you can extend that equation out to x squared plus ax plus bx plus f, and this should result in x plus a, bx plus f, something like that, right? So let's go back. Okay, let's look at this question here. Okay, so as we go back onto it, like I said before, this times b, 5 times 5, in order to make it a perfect square, must equal this value right here. And how are you going to make that happen? So what is 5 times 5? It's 25. And what's the difference between 25 and 20? Everyone should know this is a minus 5, right? So now let's write it down again. X squared plus 10x plus what the value here is 25, and then the difference, which is minus 5, right? So now you're able to approach the situation with a perfect square right here, right? So make a little bit a better line here, and x squared plus 10x plus 25. So this will again be like, everyone should know how perfect squares work. This should give you an x plus 5 squared minus 5. And when you graph this, everyone should know that when graphing a parabola, so you can see here, this is a minus 5 representing how below it is. And then this is a 5 plus 5 representing to the left. So the ability to also approach this. So now that you know the vertex should be right here. And this will give you a parabola that should look like that, going up, right? So now let me clear the whiteboard. And I will give you another question. And this results in ones that, so the general equation, you guys should know, should be ax squared plus bx plus c, right? But what if this a is not 1? So let's look at the equation right here. And I want you guys to still present this as an ax plus h squared b, right? This should be a plus b, okay? So let's go about this. This is not 1, right? So let's look at this. 2x squared plus 4x plus 20. All right. So when you're looking at the one that's not 1, you're going to look at this and you're going to be a bit confused. How do I factor this out? Especially as a perfect square right here, right? So notice that this 2 right here is factorable in this equation. So if I take 2 out here, you'll get an x squared plus 2x and then plus a 10, right? And so suppose we're going to give this a value, that's going to have this equal to e. E is another variable, right? So if this is all equal to e, and then now you have to factor it out. Make sure that this 2, you don't just forget about it in the equation. Only if it's equal to 0 is when you can forget about it. So we're going to look at this as x squared plus 2x plus 10 equals e over 2. right? And now we can use the same method as we did before. All right, I want to make sure you guys are taking notes. Please be aware, right? So now we're going to divide this by 2. We'll give you 1 and 1. 1 times 1 equals 1. So this value here. And what is the difference? It is a plus 9, right? So now we're going to come here and work on it. So x squared plus 2x plus 1. And then as you can see, the difference is a plus 9 equals e over 2. Right? So now you're going to look at it. You're going to say an x plus 1 squared plus 9 equals an e over 2. Right? And now this is what really gets everyone, right? So you look at this perfect square, and when you obviously when factoring this, you want to find your a value right here, this a value in the format, right? That just happened. Okay, you want to find the a value of the formatting right here. And so you know that this e over 2 is not what should be there, right? This should all equal to e, and this function right here should equal to e. So see that divided 2, now you're going to multiply all the sides by 2. So if I put this in a bracket format, and then this will equal e, right? So now when looking at it, know that you can attach this as a coefficient to x plus 1 squared. And then many people just leave this plus 9 because they don't know, oh, wait, the 2 should just multiply the x plus 1, right? No, it should also multiply this 9 right here. So there'd be 2 times x plus 1 squared plus an 18 equals e. And that is your answer. So in terms of a general formatting of this question, a equals 2, h equals 1, and then b would equal an 18. That's your answer. Okay. So now that we have practice, I want to have an equation done by you guys. So given the format a plus x, or sorry, let's try to switch that up. Okay. So given the format x plus h squared, I want to ask that a as a coefficient, right? Plus k equals e. What is k? And suppose I'll give you an equation right here. Let's look at 3x squared plus 9x plus, let's give or take 33 equals e, right? So what is k? I want you guys to first pause this video and work on it. I'll be going over it in about 10 seconds. So pause, and then we'll go over it. Okay, I hope you guys are back after solving this equation. Make sure that you pause the video and do it, all right? So let's look at this equation right here. 3x squared plus 9x plus 33. Like we saw before, whenever finding an a as a coefficient of this, this should always be a factorable in equation, right? So let's look at the factor here. What is factorable here? If you guess 3, you're correct. So you're going to say 3x squared plus 3x, which obviously you know the distributive property, and then plus 11 equals e. All right. So now you want to factor this 3 out to isolate x as an equation here. And then remember, this is going to be a little bit iffy. We'll go over why it is. Okay, so x squared plus 3x plus 11 equals e over 3, right? So now let's look over this equation. So when finding the perfect square, you want to divide this by 2, and what will that give you? That'll give you 3 over 2, 3 over 2. And now you're wondering, what? How do I square this? So what is 3 times over 2 times 3 over 2? Everyone should know it's numerator times numerator and the denominator times denominator. So it'll give you a 9 over 4. And what is that difference with 11? So if we go over the side here, let's come here. 11 equals 44 over 4, right? It's a simple equation. You want to make sure you have a common denominator, this 4, and then this 4, right? So the difference right here should be a 44 minus 9, which in turn gives you a 35 over 4. Okay, so now let's look back at this. It's going to give you x squared plus 3x plus 9 over 4 plus a 35 over 4, right? Let me rewrite this. Okay, plus a 35 over 4. equals an e over 3. Okay, so now this is actually be easy. As we know, it's a 3/2 as the perfect square. So x plus 3/2 squared plus 35/4 will give you an e over 3. Now you know the next step is to factor this e out to make it by yourself right here, like this should be. Okay, so now you're gonna get 3. It's gonna go brackets here. X plus 3/2 squared plus 35/4 equals e. Okay, so now you can just factor this out, right? 3x plus 3/2 squared plus, and this is your answer right here, equals e. And we're looking for k in this given equation, k right here. Okay, so let's look at this, right? Let's look at this a bit on the side. We'll draw a little square for our work. This is, especially when doing work in math, make sure you draw little squares to identify what you're doing. Okay, so this is your answer, right? So you're gonna get 3 times a 35/4. Okay, so you want to make sure that you don't mess this up. Because sometimes I see students, instead of multiplying the 3 to 35, they multiply to 4, and that will give you a completely wrong answer. So you want to make sure that 3/1 times a 35/4. This is simple algebra, guys. This should be easy. So what is 35 times 3? You can plug it into a calculator, or you can just do it in your head. It's 3570, and then it's going to be 105/4, right? And when making sure, when doing these equations, you want to make sure you factor or simplify as much as possible. Is 105/4 really simplified? Is it already simplified? It is. No ways of doing it more. The only way to factor 4 would be to divide by 4 and divide by 2. And as you can see, this is an odd number right here, right? So the answer you should get is a 105/4, right? So make sure you guys know how you do this work. Okay, so now we're going to go over one last question. We're going to end off this week's worth of algebra. A review of algebra that will be key for pre-calculus. Okay, so this is going to be a little bit different, right? So you want to make sure that, so if I ask you what is 1/3 equals x, right? What is x? Everyone would know that given an actual like real number, x would equal 0.333 continued, or another way of writing it would be a 0.3 and then a little dot right there, right? So how do you get to find that? And suppose I'll give you this. I'll give you like 0.527 dot equals x, and then write x. And this, guys, this is a little bonus section here, but this is also really important for future pre-calculus and algebra in itself. So write x as a fraction, right? So now what I want to do is I want to sort of factor this so that it can be easily subtracted by each other, right? So if you have x equals 0.527, I will redo that line. Guys, I just got it. I got a new tablet, so please be patient in this process. Okay, so now you're looking at this phi 2 and then this little 7 right here, and you want to subtract it so that this infinite 7 subtracts by each other after this point right here, this decimal point right here. Okay, so let's look at this. Let's look at 100x. What would that equal? Well, if you move this 1, 2, it'll give you 52.7, like that, right? And now let's look at 1000x. Make sure it lines up a bit, guys. And so when you do 1000, you move 1, 2, 3. So it'll give you 527, decimal point 7, and then continued, right? So now you're looking at it like, wait a minute, I can factor this, right? So now let's subtract 1000 by 100. That will give you a 990. Or sorry, no, it doesn't. It will give you a 900, right? 900x equals, what does it equal? Well, you want to subtract 527 right here minus a 552.7. So you can see these two cancel out, and that literally really just gets you out of this little continuous line right there, right? Just get you out. So that gives you an equation itself. So 900x equals, and now you just do 527 minus 52. And let's show our work here. 527 minus 52. Make sure you guys don't use your calculator for these kind of questions. Give you a 475, right? So now you come back to it, 475. X equals 475 divided by 90. And can you factor this? Of course you can, right? Let's first go by 10. This is a little method I want to teach you guys. Instead of just dividing by 5, you can divide by 10 and then multiply by 2. It makes it much easier. So you have x equals, let me get rid of these lines. Okay, so let's go back to this. X equals 47.5 over a 90, right? And you want to make sure that you don't have any decimal points left. So it'll be an x equals, I believe this is a 95. Yes, 95, and then this is a 180, right? And I believe you can factor this even more, right? This will give you an x equals 19 over a 36, right? And then let's try and check your work here. So 19 over 36. What you can do is you can simply just go on the computer and you can just do 19.3 divided by 36. And look at that. It gives you a 0.527777, which is essentially what we're asking for right here. So this is a little bonus part, and I hope you guys enjoyed this section right here. This video was an introduction, was just a recap of perfect squares that must be memorized for pre-calculus. Next week, we're going to go on to our first actual pre-calculus lesson. Not really first, but our third actual pre-calculus lesson, sorry. And we'll be going over more on the review of this algebra that you will need to know for pre-calculus. Remember that pre-calculus is an introduction to calculus. So knowing how to do trigonometric functions, such as cosine, cosecant. Remember, there's cosecant, there's secant, and there's cotangent. Those three are the trigonometric functions that you must memorize, alongside obviously the common sine, cosine, tangent. Remember, those are the reciprocals, and that's what we're going to go over next week for this lesson. I hope you guys enjoyed, and I hope you guys also enjoyed the tablet method that I'll be using much more. And this little bonus section that I taught you guys here. Remember, this is sort of abstract mathematics. You have to think about this in a different method. So if I ask you, like, look at this equation right here, like 0.0527 equals x, right? And you're like, how do I solve this? Well, if you know abstract algebra, or it's not even abstract, just abstract mathematics, the ability to just know how to work it, you will be able to find it. So I hope you guys enjoyed this lesson, and I'll see you guys next time. Have a good time.